that do not touch each other. Now, the reason this is fantastic is because it allows us to solve some good problems in geometry. So let's walk through these postulates and theorems a little bit at a time. So first, the corresponding angles postulate. Okay, now I've deliberately written in the word postulate and crossed it out. This is because many textbooks will call this a postulate, but it's really not true. It's actually a theorem. This can be proved. We're not going to prove this in this video, but please know that this can in fact be proved. Okay? Well, let's see what this says. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Okay? So one way to help us understand this is to draw out some pictures. So let's say you have a line here. We'll call this line 1. Draw another line here. We'll call this line 2. Okay? And then there's got to be a transversal of some sort. So I'll draw this in here. Okay, so L3 here is the transversal. And then I am going to number some of these angles here. So we'll call this angle 1, 2, 3, 4, 5, 6, 7, 8. Okay, you can number them however you'd like, but that's how I've chose to do this. And when we work with a theorem or a postulate, we try to express the text in symbolic mathematical notation. So if two lines are parallel and they're cut by a transversal, this basically says if L1 is parallel to L2, then the pairs of corresponding angles, and here's the key, is that you have to know what corresponding angles mean. But from this picture you can see that 1 and 5 are corresponding angles, 8 and 4 are corresponding angles, 3 and 7 are corresponding, and 2 and 6 are also corresponding. So we can say any of these statements. 1 is congruent to 5, 4 is congruent to 8, 3 is congruent to 7, and 2 is congruent to 6. Okay? So all of these are true if these lines are parallel. So that's the important part. If these lines are not parallel, then we can't say anything about this at all. And again, we are not going to prove this here in this video, but please know that this is in fact a theorem that can be proven. Now, let's continue, and we'll go on to the next theorem, which is the alternate interior angles theorem, and we'll actually look at a proof of this one. So this theorem says if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So let's look at this picture. If we have two lines here, we'll call this again L1 and L2. And then there's a transversal that cuts it. And I've also numbered them, and just like I did above. And so we can say if L1 is parallel to L2, then alternate interior angles, these things, in this case it would be 4 and 6. 4 is congruent to 6, and also 3 is congruent to 5. Okay, so this is understanding. This is just a matter of writing out the text in mathematical form, and also it's a matter of knowing what the definitions of these angles are. And in this particular example, we are actually going to do the proof of this. Proof, the given parts are the if statements. Okay, so if statements are always the given part, and then the conclusion, or the part that follows then, these are what we're trying to show. So we're going to assume that L1 is parallel to L2 and show that it must always be the case that angle 4 is congruent to angle 6. Now we're not going to prove the part for 3 and 5, but you can follow this proof and try and do this on your own. It's basically the same steps. Okay? So I'm going to start out with the first statement, which is that L1 is parallel to L2 because this is given. Okay. Next, I'm going to use the previous theorem that we had up here, which says to me that angle 4 okay, must be congruent to angle 8. This is the part that I'm going to use from up here. So angle 4 is congruent to angle 8 because of the corresponding angles theorem. Now, before we go too far into this, it's important to see kind of the big picture of the proof before we try and to write out too many things. But from this, you can see that angle 4 is congruent to angle 8, okay, because they're corresponding, and angle 8 is congruent to angle 6 because they are vertical angles. So again, 4 is congruent to 8, and then 8 is congruent to 6. Therefore, 4 and 6 must be the same. Okay, so let's write this out. Angle 4 is congruent to angle, angle 6 is congruent to angle 8. Angle 6 is congruent to angle 8, the 6 and 8 right here, because they are vertical angles. And then for the last step, we can see that 4 is equal to 8 and 8 is equal to 6. That means 4 must also be equal to 6. And the rationale here is the transitive property. Okay? So I'm using a lot of properties here and maybe some postulates later on and some definitions here. So it's important that you understand exactly what these words mean. If not, go back and look at your notes or look at some examples from a previous lesson on these items so that you can know what they mean. Okay, the focus here is to work on the proofs. Okay, so there you have it. Now we're done. We wanted to show that 4 is equal to 6, and we've shown that in here. So I'm going to end this video here, and I'm going to continue with another video that deals with the other two theorems here. As always, if you need help, ask your teacher. Have a wonderful day.